When we say the internet, it sounds like one enormous system, one network, one infrastructure, one connected world. But that is not what the internet really is. The internet is made of thousands of independent networks, telecommunications providers, cloud platforms, universities, businesses, governments, content companies, each with its own infrastructure, its own systems, its own customers. Yet somehow, all of them can communicate. A message can leave one network, travel through another, and eventually reach a completely different network on the other side of the world. How is that possible? Because the internet was never designed as one giant machine. It was designed as a system of networks that could connect with one another. And somewhere, those networks need to meet. Imagine hundreds of highways arriving at the same intersection. Instead of cars, imagine information. Instead of roads, fiber optic cables. And instead of traffic lights, high-speed networking equipment directing enormous volumes of data. This is the basic idea behind an internet exchange. Different networks connect to the same physical location and exchange traffic directly. A telecommunications provider can connect with a cloud platform. A content company can connect with an internet service provider. A research network can connect with another research network, all within the same physical infrastructure. The concept is simple, but the impact is enormous. Because when networks meet directly, information no longer needs to take unnecessary journeys. Every piece of information traveling across the internet has a route. Sometimes that route is simple. Sometimes it is surprisingly complicated. Data can pass through several networks before reaching its destination. Every additional connection can introduce delay, additional costs, and additional opportunities for failure. Direct interconnection can change that. When two networks connect directly, traffic can take a shorter and more efficient path. For ordinary browsing, the difference may seem almost invisible. But the digital economy operates on enormous scale. Millions of businesses, billions of users, financial transactions, cloud applications, video platforms, artificial intelligence. When the same improvement happens billions of times, milliseconds begin to matter. Because the internet is not only about moving more data, it is also about moving that data more efficiently. Most people will never see an internet exchange. From the outside, it may look like an ordinary building. No giant antenna, no enormous satellite dish, no obvious sign announcing its importance. But inside, the story is completely different. Network equipment operates continuously. Fiber optic connections arrive from different parts of the city. Some connections come from distant regions. Others connect directly to major data centers. Different networks establish relationships, and information begins flowing between them. Millions of digital interactions can pass through infrastructure that almost nobody notices. There is something fascinating about that. Some of the places most important to the connected world are almost invisible within it. Speed is not simply a technical advantage. In the digital economy,
speed can become economic power. Financial institutions depend on rapid communication. Cloud platforms depend on efficient data movement. Businesses depend on responsive applications. Content platforms must deliver enormous amounts of information without unnecessary delay. For these systems, a few milliseconds can matter. A more efficient network path can improve performance, reduce unnecessary traffic, and sometimes reduce the cost of moving information. That is why internet exchanges are more than technical facilities. They are economic infrastructure. They help create a more efficient digital marketplace. And beneath the speed of modern commerce, there is often a physical network making that speed possible. Something interesting happens when more networks join the same exchange. The value of the connection increases. One network has limited possibilities. 2 networks create a direct relationship. 10 create many more. Hundreds create an ecosystem. The more participants connect, the more opportunities exist to exchange traffic directly. And that creates a powerful network effect. A successful exchange becomes increasingly valuable because other networks are already connected there. It becomes more than a technical facility. It becomes a digital crossroads, a concentration point for information, a place where different parts of the internet become closer, faster, and more interconnected. It comes from connection. Perhaps the most important idea behind an internet exchange is not speed, it is cooperation. The internet was never designed around one organization controlling everything. Instead, independent networks agree to communicate. Internet exchanges provide physical places where that cooperation can happen efficiently. Different organizations, with different businesses, different infrastructures, and different objectives, can connect to one another. No single network needs to own the entire system. That creates flexibility. New networks can join. New services can emerge. New connections can be established. And the internet can continue expanding without requiring one central authority to build every connection. The strength of the system comes from its ability to connect independent parts. A global network cannot depend on one path. Cables can fail. Equipment can break. Construction can damage infrastructure. Natural disasters can disrupt connections. And sometimes, entire facilities can become unavailable. The answer is redundancy. Multiple paths, multiple connections, multiple facilities. If one route becomes unavailable, traffic can move through another. Internet exchanges become part of this larger architecture of resilience. They provide additional opportunities for networks to connect and additional routes for information to travel. This reveals an important principle of modern infrastructure. Reliability does not mean preventing every failure. That is almost impossible. Reliability means designing systems that can continue operating even when something fails. Cities compete for investment, for businesses, for talent, for innovation. But increasingly, they also compete for digital infrastructure, data centers, fiber networks, internet exchanges, cloud connectivity, reliable power. Because a modern city is no longer defined only by roads, buildings, ports, and airports. It is also defined by how efficiently information can move through it. A city with dense digital infrastructure can attract businesses that depend on speed and connectivity. Financial services, technology companies, cloud platforms, media, research, and increasingly, artificial intelligence. The digital economy may operate globally, but its infrastructure is still deeply physical and deeply local.
The internet appears to be everywhere, but its infrastructure exists somewhere, in cables, in data centers, in routers, in servers, and in places where networks meet. Internet exchanges may never become famous. Most people will never know where they are, yet they quietly perform one of the most important functions in the digital economy. They allow independent networks to become one connected system. And that simple idea changed the scale of human communication. The internet is not powerful because one network controls everything. It is powerful because thousands of networks can connect, cooperate, and exchange information. That is the architecture beneath the digital world. Invisible, physical, and constantly moving. NEXNET, the architecture of modern civilization.